Hi guys, so we are going to be continuing with our Chapter 8 notes on similarity. Today we are going to be proving triangle similarity by side, 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 and side angle side similarity. This should sound familiar because we did cover these congruency theorems a couple chapters ago. So still the same concepts, except we are adding in our ratio similarities that we just learned in our last lesson. So for side, side, side similarity, pretty self-explanatory. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. So that means that all three sides have to have that same ratio for the triangles to be similar. So rolling right into our first example, it says, is either triangle DEF or triangle GHJ similar to ABC? So we have to take those proportions like we did in our last lesson and see which of these triangles, or maybe both of these triangles, are similar to ABC. So I'm going to label triangle ABC as my triangle 2 and DEF as triangle 1. So at this point, we are just lining up the sides to make our proportions. So side AB goes with side DE from the DEF triangle. AB is at 8, and DE has a length of 6. Remember, you always, always, always need to simplify these fractions because otherwise your proportions are never going to look the same. So always simplify those fractions. In this case, 2 goes into 8 4 times and 6 3 times. All right, and then we just keep moving right along and doing the next sides. So from A to B, then we go to BC and EF. BC is 12 and EF is 9. Again, simplify. 3 goes into 12 4 times and 9 3 times. And the last side we have is CA and FD. CA is 16 and FD is 12. 4 goes into 16 4 times and 12 3 times. So notice for the 3 sides of these triangles that we did, 4/3 was our proportion. So automatically we know for sure that triangle DEF is similar to ABC because all 3 sides had the same proportion. So to make sure we've covered all bases, we now need to check triangle GHJ to see if that triangle is also similar. So now I'm going to label GHJ as our triangle 1, and we are comparing that with triangle ABC. So side AB goes with side DE. AB is 8. Oh, I'm sorry, not DE. We're in a different triangle. AB goes with GH. There we go. And GH is 8. When that simplifies, we just get 1. The next side we look at is BC. BC lines up with HJ. BC is 12 and HJ is 10. So already looking at this, even before we simplify this fraction, we know that 1 and 6/5 or 12/10 are not the same. So our sides do not have a similar proportion, which means that the only similarity statement we have here is that DEF is similar to ABC. In number 2, it is very similar, the same kind of concept, except it says, which of the 3 triangles are similar? Write a similarity statement. Now, we weren't given anything, like in the previous one, they named the triangles for us already. DEF, GHJ, ABC. Everything was labeled for us, so we knew which sides lined up with which sides from the other triangles. In this one, they don't do that. They just give us these triangles. So a thing to take note of when you're making your proportions to see if your sides are proportional and have the same ratios, you need to line them up with the short sides together, the middle sides together, and the long sides together. So when making your proportion statements from one triangle to another, the short sides go together, long sides go together, middle sides go together. All right, so I am going to start with triangles LMN. So I'm going to start with this guy and this XYZ. So keeping this concept in mind, short with short, middle with middle, long with long, that is how we are going to start these proportions. So looking at our second triangle, so that XYZ, our shortest side is 30. So YZ is our shortest side. On LMN, our shortest side is 20. So those are the 2 sides that we have to compare first, 30 and 20. Simplifying that, we see that 10 goes into both of these numbers. 10 goes into 30 3 times, and it goes into 20 twice. All right, so that was our short side. Now we want to do the middle side. So on our XYZ triangle, the middle is 36, that is XZ. And on our LMN, the middle is 24, that is MN. So we have 36 over 24. Let's see, 12 goes into 36 3 times, and it goes into MN twice. Okay, so we're looking good so far. So then we only have one other side to consider, and so that is our longest side. On our XYZ triangle, that is XY. And our LMN triangle is LN. So XY is 39. And LN is 26. And in this case, let's see, 13. 13 goes into both of these. 13 goes into 39 3 times. And it goes into 26 twice. So notice that our 3 sides are all the same proportion, 3 over 2. So we have actually found the triangles that are similar. There is not going to be another set that is similar. In this specific example, you just had to find the one that was similar. Just kind of lucky guess for that. I can go ahead and show you how this would look if we tried it with LMN and RST, just so we can see that those do not work, or hopefully do not work. They should not. So again, we start with our short side. So our short side would be RS, and then LM. RS is 24 and LM is 20. 4 goes into 24 6 times and goes into 25 times. Our middle length is RT, and again, MN. RT is 30, and MN is 24. And then, in this case, 6 goes into 30 5 times, and it goes into 24 4 times. So already notice that our sides do not match up. So in a case like this, and I would specify more so on a test or a quiz, it would just be to find the one similarity statement. There's only one, so you do not have to go through and now test RT with XYZ, but you could. However, I know for a fact that that does not work, but if you wanted to, you could test it, and then you would find that you've already found the similarity. So then writing our similarity statement, we would say that triangle LMN is similar to triangle YZX, making sure we line those sides up. So LM was the shortest, that goes with YZ, which was the shortest, and then MN was the middle, and then ZX was the middle, and then our last letter. And then in number 3 throws in some algebra for us. It says to find the value of X that makes ABC similar to DEF. So first thing that you want to kind of look at is where you have those X values that you have to solve for. I think this X minus 1 is a little bit easier to work with than the 3X plus 1. So that means I want to work with side BC. BC is similar to EF, and we just pulled that from this statement over here. BC is in the same position as EF. And then ED here just has 12, no variables to deal with. And ED goes with BA. Again, we pull that from our similarity statement. DE are in the same position as AB. So from that information, we can set up our proportion really very similar to our previous lesson. So we have ED is similar to BA, which gives us 12 over 4. In this case, that actually simplifies to 3 over 1, and we're going to leave that as a fraction still. And then we have the side EF that is similar to BC. So EF was 18, and BC was X minus 1. Now remember, we are trying to prove these triangles are similar, so that means that this 3 over 1 and this 18 over X minus 1 should be the same thing. So 3 over 1 should equal 18 over X minus 1. And to solve for X at this point, we just have to cross multiply. So we get 18 equals 3 times X minus 1. We distribute that 3, so we get 3X minus 3. Add this 3 to both sides, and we get 21 equals 3X. And our last step is to divide both sides by 3. And that tells us X equals 7. And then number 4, kind of a similar idea, except they don't necessarily give us pictures to look at. It says the shortest side of a triangle similar to triangle RST is 12 units long. find the other side lengths of the triangle. But then it tells us to use the image from example 2. So from example 2, we are looking at this RST triangle here. And they tell us the shortest side of the triangle is similar to RST, and it is 12 units long. So the shortest side of RST was 24. So to find our main proportion that we need to match up against, we know that the shortest side of RST was 24, and the shortest side of this other triangle is 12. Well, so in this case, 24 over 12, that simplifies to 2 over 1. So this is the proportion that everything has to match up to. So we need to find the middle length, so that middle side length, the middle longest, I guess we'll say. And we need to find the longest side. So we are using this RST triangle to find those lengths. So in RST, we've already used the shortest side, so the middle length is 30. It has to be equal to this proportion of 2 over 1. The 2 was our RST length. That 24 was the original RST shortest length. So we are going to use the middle RST length over the middle unknown length for this other triangle. We do our cross multiplying. So we get 30 equals 2x. And divide both sides by 2. So our middle length is 15. And now we need to find our long side. So again, it has to be equal to this same proportion because our triangles are similar, so they are always going to have the same proportion. The longest side in RST was 33. And then we don't know the longest side for our similar triangle. So then at this point, we do our cross multiplying, and we get 33 equals 2x. Divide both sides by 2, and we get x equals 16.5. So then our long side is 16.5. Now, we also could have used the concepts of like the area and perimeter that we covered yesterday, but I felt like just breaking it up into the middle side and the long side using that proportion was a little bit easier than trying to add in all those extra numbers. All right, so then the other similarity theorem that we are going to go over today is side angle side. So again, we have covered this before when we were looking at our congruence statements. This states that if an angle of one triangle is congruent to an angle of a second triangle, and the lengths of the sides including these angles are proportional, then the triangles are similar. Sorry, there's a little typo there. That should say, then the triangles are similar. There we go. So remember, if we have this triangle and we say that this is our congruent angle, then this side and this side would have to be proportional to our second triangle. So see how those two sides include that angle? So side, angle, side. So they actually form an angle. That is what proves side angle side similarity. So we are going to work with using these two theorems to show that these triangles are similar. So they give us this statement and say that SRT is similar to PNQ, but we kind of have to prove that. So notice that this angle is a right angle and this angle is a right angle. So obviously those angles are congruent. So angle R is congruent to angle N. They're both 90 degrees, so they have to be congruent. So now what we need to do is look and see if those sides that include that angle are proportional. So we need to make sure that PN over SR is equal to NQ over RT. So we need to make sure that they have the same proportion. So PN is 18 and SR is 24. 6 goes into 18 3 times and 24 4 times. And then NQ is 21 and RT is 28. 7 goes into 21 3 times and 28 4 times. So notice that our sides are in fact proportional. So this proves that these triangles are similar by side angle side similarity. That little squiggle after just says that we have a similarity statement. Now, this next one gets a little tricky. So we have triangles XZW and YZX. And the only information they tell us about the angles is that angle Z here is 90 degrees. Now, we want to assume that angle Z is also 90 degrees. So, I'm sorry, the other side of angle Z is also 90 degrees. However, they didn't specify that. So, it's kind of hard to tell. Everything looks like it has to be 90 degrees, but we just don't know. So we can't say anything about that. But XZ on both sides has to be 12. So remember, these are like two separate triangles. So we have this one. That does not look like a right triangle at all. There we go. So we have this one for WXZ. This side's 20, this side is 12, and this side is 16. And then we have this other triangle of XZY, where this side is 12, this side is 15, and this side is 9. And then we know that this angle is 90. Since we don't know if our other angle of Z is 90 because they didn't specify, we have to look and see if this has side, side, side similarity. So remember, you have to put your short side with your short side. So we would have side ZY with side ZX. ZY is 9, ZX is 12. 3 goes into 9 3 times, and it goes into 12 4 times. Then we do our middle side. So we would have XY over WZ. XY is 15. Oh, nope, that's not right. That's not right. My middle side is ZX and WZ. There we go. So that gives us 12 over 16. 4 goes into 12 3 times, goes into 16 4 times. And then we have our long side of xy and wx. Xy is 15, wx is 20, 5 goes into 15 3 times, and 20 4 times. So notice all three of our sides have the same proportion, so these are similar by side, side, side congruence. And last but not least, of course, is one of our real world situation problems. It says you are building a lean-to shelter starting from a tree branch as shown. Can you construct the right end so it is similar to the left end using the angle measure and lengths shown below? So this is our left and this is our right. So notice right away that it's kind of hard to tell actually, but this angle 53 is angle P, nope, that's an F, angle F and angle A. So angle F equals angle A, which is equal to 53 degrees. So therefore, angle F is congruent to angle A. So we already have that those angles are congruent. So now we just need to see if those sides coming off of the angles are proportional. So we need to see if AC over FH is equal to AB over FG. So AC was 15 and FH was 10. 5 goes into 15 3 times and 10 twice. And then AB was 9 and FG was 6. 3 goes into 9 3 times and 3 goes into 6 twice. So again, notice that those side lengths are in fact proportional. So the left and right side are similar by side, angle, side, similarity. So triangle ABC is similar to triangle FGH. And that completes our notes for today.